Hey guys, we are back with a new topic, that is mean and standard deviation for Poisson's distribution. Okay, so in previous video or in some previous lectures, what we have discussed is mean and standard deviation for using binomial distribution. Okay, so here we are considering Poisson's distributions. There we have used binomial distribution, so it was having a formula of p of x is equal to ncx into p power x into q power n minus x. But in this case we are using a different formula, that is different name, that is Poisson's distribution, which is nothing but p of x is equal to m power x into e power minus m divided by x factorial. So this is the formula for your Poisson's distribution. So by using this formula we need to find the mean and the standard deviation. So this is the derivation. Okay, so both derivations are also important. Okay, so let's start. So same procedure, what the procedure you carried on to that derivation, the same procedure follows here also, just some with minor changes in this, just nothing but this formula. Okay, this formula, and there are some changes in between. I'll say you. Okay, so now at the starting point, you know the mean formula. Mean mu is equal to sigma from x0 to infinity x into p of x. You are all familiar with this formula. Okay, fine. So here we need to again substitute the p of x formula. So at the previous derivation, that is binomial distribution, the p of x value was different. So here p of x value is this. Okay, just you need to substitute this in place of p of x. You need to substitute this formula. Okay, and place the x as it is. Okay, fine. So what is this formula? By m power x into e power minus m divided by x factorial. Okay, okay. Now I need to expand my x factorial. How I can expand? As I told in previous video, that is x factorial is nothing but we can write as x into x minus 1 factorial. Okay, so if I write this, my x and x gets cancelled. Okay, so again I did some modification for p. There in binomial distribution I have done for p of x. How did I separated them? How did I splitted them? P into x minus 1. What all the reason why how I have splitted this, I have told in the previous video. Okay, similarly in this case I will split for my m power x. M power is nothing but m into m power x minus 1. Okay, fine. M into m power x minus 1. Okay, x gets cancelled. Now all the terms, the constant terms, that is e power minus m and m, I'll take it outside the summation. Okay, so inside my summation the remaining thing will be m power x minus 1 divided by x minus 1 factorial. Okay, so you may get a small doubt that here earlier it was summation from x is equal to 0 to infinity, but as we gone to the further steps, it got converted to x is equal to 1. Why? Because see, if I expand this formula, if I substitute here x is equal to 0, then whole term will be 0. It should not be like that. Okay, so that's why if it has to be some value. Okay, that's why we have changed it to 1. If I substitute 1, then there will be some value. Okay, some valid value. Okay, it won't be equal to 0. Okay, fine. Okay, then again, so here I have taken the constant term outside. Okay, now for these things I'll apply my summation and expand this formula. Okay, how can I expand? See, x is equal to 1 to infinity means x is equal to 1, 2, 3, 4. So in place of x, I need to keep on substituting my x value and gone adding them till my x value encounters to infinity. Okay, that means first x place 1 and put in x place 1. Okay, plus next second 2 to place put 2 in place of x. See, 2 and put 3, put 4, put 5 till infinity. You have to carry out. I have written till 3 only, just to made it simple. Okay, so by seeing this we'll get a formula in our mind, that is known as Maclaurin series. In first sem we have studied that Maclaurin series has the same formula, that is e power x is equal to 1 plus x by 1 factorial plus x square by 2 factorial plus so on. Okay, so even in this case also, if I substitute this, see, m1 minus 1 is 0. See, wait, I'll do here, m1 minus 1 is 0, so m power 0, 1 minus 1 is 0 factorial, and 0 factorial is nothing but 1. Okay, so 0 factorial plus m2 minus 1, m power 1, 2 minus 1, 1 factorial, plus m3 minus 1, m square, 3 minus 1, 2 factorial. Okay, so this is nothing but your m power anything to the power 0 is 1, 0 factorial is 1, 1 by 1 is 1, plus m divided by 1 factorial plus m square plus 2 factorial, and so on. Okay, similarly this formula is also like that only. Okay, see, 1 plus x by 1 factorial, x by x square by 2 factorial. So just in place of x we need to replace m. ठीक है ना, तो e power x we have here, we'll take e power m. Why m? Because we have in place of x we have m here, so that's why we'll replace it m. E power m is nothing but 1 plus m by 1 factor. That's what I have written here. So just you need to substitute in place of this whole thing, I'll substitute e power m. Okay, fine, I'll replace it. Okay, so this is the outside thing, you should not forget it. What we have taken outside the summation, that is the constants m into e power minus m, that we have to keep as it is. Okay, then in place of this big formula I need to substitute my small formula, that is e power m. Okay, now you know that bases are same, powers gets added. If my base is same, then I'll write it as one time. Okay, then minus m plus m gets cancelled, e power 0 will come. E power 0, anything to the power 0 is nothing but 1, and 1 I no need to write 1, so the remaining will be m. So my mean formula for by using Poisson's distribution is m. Okay, clear. Okay, so next my agenda is to find the standard deviation. Okay, now, okay, to find the standard deviation I need to find the variance. As in previous videos what we have done, the previous exactly the same, just some formula, some things, some variables, some constant gets changed in this derivation. The procedure remains same. Okay, so we have variance. You are still familiar with this formula also, sigma summation x is equal to 0 to infinity x square p of x minus mu square. Okay, so consider it as equation 1. Okay, now consider there are two parts, right? Consider this only this half part. Okay, this only consider this part, simplify it, then substitute it, then you will get to your variance. After you get variance, you just put a square root, then that will be your standard deviation. Okay, so now consider this one part. Okay, I have considered here. Okay, so now sigma summation x is equal to 0 to infinity, and x square, this x square I have converted to this. Similarly, in my previous video, that is binomial distribution derivation, same how I should convert this x square into how I have converted, you can see there, but also I'll say, okay, x square is nothing but I can convert it in x into x minus 1 plus x. Why I have converted to like this means, if you simplify this again, see, x into x, x square, x into minus 1, minus x. Okay, and this is plus x, so plus x minus x gets cancelled, again you are going to get x square. Just we need to split this x square to this. Okay, p of x as it is. Now there are again two terms in this, so this is first term, this is second term. Now multiply, p of x will gets multiplied to both the terms. Okay, p of x multiplied by x into x minus 1, so this will be a term with summation. And next, p of x multiplied with the x, and okay, followed by your summation also. Okay, fine. Okay, till here it's okay. Okay, now you have seen this formula, sigma summation x is equal to 0. See, summation x is equal to 0 to infinity x into p of x, same formula you have. Okay, so what if we simplify this, what the answer we got? M. So nothing but we can directly substitute in place of this formula, directly I can substitute here m. Okay, na? Okay, fine. Now here I have summation from 0. See what happens if I take here summation 0. If I take summation 0, the value will be negative. So 0 0, and first of all the whole term will become 0. Okay, so that should not be the case. If I substitute 1 here, again 1 minus 1, that condition also will be brought up me to 0. That should not be the case. Again 2, if I put 2, there will be some value, so I'll start my summation from 2. Okay, from x is equal to 2 to infinity. That's why I have taken here x from 2, the value of x varies from 2 to infinity. Fine. Okay, now put the values as it is. Now you put the formula, Poisson's distribution, what we have, p of x formula, you just put it, that is m power x into e power minus m divided by x factorial. Okay, now again what did I say in the previous lecture also, same, x factorial, how can I expand it? X into its previous one, x minus 1, its previous one, x minus 2 factorial. Okay, now x gets cancelled and x minus 1 gets cancelled. Okay, fine. Now again I need to split my m power x. Okay, for in this case, in variance case, I can split it as m square into m x minus 2. Similarly, what I have done in my binomial distribution, that just it was p square into p power x minus 2, but here is m square into mx minus 2. Okay, na? How this I have converted? This is simple. I have already said you. Okay, m square, just for m power x I have splitted here. See, if you are getting some sort of doubts that how I am doing this splitting process, then you can visit my previous video, that is mean and standard deviation using binomial distribution. There I have clearly I have explained you that how and what the modifications need to be done. So again and again I can't able to tell those things, just I'm saying orally. Okay, for m power x, just I have splitted here, m square into m to the power x minus 2. Okay, e power minus m as it is, and then this all have get cancelled, remaining is x minus 2 factorial. Okay, now put all the constants aside outside the summation, that is your m square into some e power minus m outside. Okay, remaining will be the m x minus 2 divided by x minus 2 also, and plus m. You need not to forget this m. See, again this part, second part also we have got this m, and this you need to carry out here also. Some students, even I have forgot to put this m, so be careful with this m. Okay, fine. Okay. So now again, if you expand this using your summation, what will be the case? First you will be substituting in place of x2, next 3, next 4, and followed till your infinity encounters. Okay, so 2 minus 2, now 3 minus 2, 3 minus 2, 4 minus 2, 4, 5 minus 2, 6 minus 2, followed to the infinity. Similarly, 2 minus 2 is 0, 2 minus 2 is 0, m power 0 is 1, 0 factorial is 1 plus again plus m. Okay, now again you got the same formula, that is nothing but your Maclaurin series formula. What we have got the Maclaurin series formula, if e power x in place of x we have m, again we got same, in place of all this we can replace it as e power m. Okay, and just the extra thing will be plus m here. Here it wasn't there, m plus m, it wasn't there in this case, that means mean case, but in variance case it is there, plus m. Okay, fine. Now what did I say? If you multiply this, bases are same, powers gets added, minus m, plus m gets cancelled, you're going to get just m square plus m. This you consider as equation 2. Now you substitute this equation number 2 in your equation number 1, that is your variance. So just this part we have simplified. So this is the simplified answer for that first part. Now you substitute in place of this minus mu square. Okay, if you substitute plus square, this is the first part simplification answer. Okay, I have put it. Now next, minus mu square. Minus mu square is nothing but, so what is our mu? Mu is equal to m, then my mu square will be m square. Okay, simple. Mu square will be m square. So this is now plus m square minus m square gets cancelled. My variance will be only m. Okay. So here in this case my mean and variance is same. Okay, but I need standard deviation. How can I get standard deviation? Just you put it a square root to whatever you have got the answer for your variance. I have got my answer for variance is m. Now just put it a square root for that. That is nothing but your square root of m. So my standard deviation, which is nothing but sigma, is equal to under root m, and my mean mu is equal to m. So clear? Okay, I hope you have you are cleared in this, okay, because I have that confidence that you have already seen my previous video, that is binomial distribution. So I hope you are clear. If you have any doubts or any sorts of queries, then you can comment down. If you have something in my something queries or some faults in my teaching, then you can comment me. Okay, so fine, in next videos we'll be discussing about problems on both binomial distribution and Poisson distribution. Okay, okay, fine, bye.